Today we're going to be starting the credit 2 of semester B, lesson 17.1. So make sure you go to page 8 to get started on that. So we're going to be learning a little bit about polynomials. So we're going to come up with names for polynomials, and we'll learn some of the terms that have to do with these polynomials. So let's complete this table real quick. So activity, complete the table below. For the term y to the 1/2 minus 17y, can any term of a polynomial have a fractional exponent? No, it can't. So we'd say that this isn't a polynomial. Can a polynomial have a negative exponent? No. Can any term of a polynomial have a variable in the denominator? No. We learned in the previous credit that whenever you have a number on the denominator, it means that it has a negative exponent. So these two things are kind of the same thing. X to the negative 1 is 1 over x. So none of those things can happen in a polynomial. So if you're going through this video on your own, make sure that you pause the video and read through some of these examples, and I'll do this activity with you. So 4t to the 4th minus 9t to the 3rd minus 17t to the 4th plus 10t to the 3rd. Well, we're looking for like terms, so we have like terms here whenever we have a t to the 3rd. So we have negative 9t to the 3rd and 10t to the 3rd. And then our other like terms, t to the 4th. So we have our 4t to the 4th and our minus 7t to the 4th. Those are our like terms. This one, I think you can pause the video and try this one out. Tell me what the like terms are here. So remember, it's just whenever the variable has the same exponent, or they're both whole numbers, like these two would be like terms, right? Then you can actually add them together. They are like terms. So now we're going to look at classifying polynomials, so giving them a name. We have monomials, binomials, trinomials, and then polynomials with more than 3 terms. We just call them polynomials. Let's do some of these examples. This one's done for us. We'll just read through it real quick. So here, how many terms are there? So the parts that are adding are the terms. So there's 1, 2, 3 terms. So this polynomial has 3 terms, so then we classify it as a trinomial. The degree of the first term is 3. Right? 4x to the 3rd is the first term, and it's 3. The degree of the second term is 2. It's the exponent on the x. The degree of the third term is 1. There's an invisible 1 in the exponent of that x. The degree of the trinomial is 3. The trinomial is 3, okay, since it is the largest degree of the 3 terms. So that looks weird, so I'm just going to erase that. That's supposed to go there. We're going to look at the degree of each term, and then the one that's the largest is at the actual degree of the polynomial, all right? So here we have 1, 2, 3 terms. So the polynomial has 3 terms. So then we'll classify it as a trinomial. The degree of the term 3x squared y squared, right? I just got it from here. Right here, is, so whenever we have multiple variables, we have to add the exponents together. So if it were just, if this y squared wasn't there, it would just be 2, right? So, but since we have these 2 variables multiplying together, we have to add the exponents. So it's 2 plus 2, which is 4. All right, the degree of the term 3xy squared is, so here the exponent of the x is 1. The exponent of the y is 2, so when we add those together, we get 3. And then the degree of the term 5xy is, well, the exponent on the x is 1, the exponent on the y is 1, so it's just 2. And now the degree of the trinomial is, we want to look for the one with the largest degree, the term with the largest degree. It's this one, right? So the largest number is 4, since it is the largest degree of the 3 terms. So there are 3 terms. I'll put the word 3. I'll spell it out so that we don't get confused with naming degrees. So 3 terms. All right, if you don't get it yet, no big deal. We have another example, and we're also going to work on these together, so you're going to be fine. So here, the polynomial has how many terms? How many parts are adding? 1, 2, right? Or subtracting, obviously. So the polynomial has 2 terms. We classify that as a binomial. And the degree of the term, the first term, 8ab squared is, well, the exponent on the a is 1, the exponent on the b is 2, so that's 1 plus 2 is 3. And then the degree of the term negative 3a squared b, I don't think I put a negative on the other ones, but that's okay, is 2 plus 1 is 3. So the degree of the binomial is 3, since it's the largest degree of the 2 terms. All right, I want you to pause the video and see if you can get as many as you can with this. Okay, so pause the video real quick. Let's try it out. Okay, so hopefully you tried this one out and you're just checking your answer now. The polynomial has 1, 2, 3 terms. So then we'll classify it as a trinomial. The degree of the term x squared y is 3, 2 plus 1. The degree of the term negative 9x to the 4th y squared is 4 plus 2, 6. The degree of the term 3xy is 1 plus 1, 2. So the degree of the trinomial is 6, since it is the largest degree of the 3 terms. Okay, so now we're going to learn about writing polynomials in standard form. So standard form is whenever here we go. The polynomial is arranged in descending order when the terms are written from left to right in order of decreasing degree. So the term with the highest degree goes first, the term with the smallest degree goes last. So let's try these ones out. The degree of this term here is 0, the degree of this term is 2, the degree of this term is 5, this one is 3. So this one is going to be written first, then second, then third, and then fourth. All right, let's try it out. So we get x to the 5th plus 4x to the 3rd minus 3x squared plus 10. Here the leading coefficient we get from this term right here. The number in front of that term, the numerical factor here is 1. Right, if it's not there, it's 1. There we go, that's all we had to do. Okay, so now this one, the standard form, let's do the same thing. So the degree of this term is 5, the degree of this term is 8, the degree of this term is 1. Right, so standard form, we're going to go in order from biggest to smallest. So this one's going to go first, and we want to make sure that we take the sign with it. So negative 3y to the 8th plus 18y to the 5th plus 10y. Right, and then the leading coefficient we get from this term, the leading coefficient is 3. Okay, some more examples. Excellent. Hopefully we're getting it. So here we have that we need to put it in standard form. So here we have this degree is 2. This degree, whenever it's just a number by itself, it's 0. 5. The degree is 3. And then this degree is 4. So then we're going to write this one first because it's the biggest, that has the largest degree. So 7x to the 5th minus 5x to the 4th plus 2x to the 3rd plus 4x squared minus 3. And then the leading coefficient we get from this term, and that leading coefficient is 7. All right, now this one. Now I'm not even going to do the degrees, but which one has the largest degree? This one, right? 14t to the 7th minus 10t to the 5th plus 7t to the 2nd minus 14. Here, the leading coefficient we get from here is 14. Here we go. So now we're going to be simplifying polynomials, which is basically combining like terms. So we're going to look for terms that have the same degree, and we're going to add them together. So x squared plus 5x to the 3rd plus 2x squared. X squared and 2x squared are like terms. So whenever we add those together, we get 1x squared plus 2x squared. That's 3x squared plus 5x to the 3rd. All right, now the next one, we have some x to the 4ths. And then we have a regular number and another regular number, a 0 degree term. And then we have a 5 degree term. So whenever we put those together, we get negative 2x to the 4th and positive 2x to the 4th. That's 0. 16 and 9. What is that? 25. And then just the regular old minus 3x to the 5th. So now, whenever we put those together, we get 25 minus 3x to the 5th. All right? I'm not going to write it like that anymore, but I just wanted you to see how I was combining them. So now, this one, AB, so we have AB minus 5AB, and then no more AB. So when we put those together, AB minus 5AB, 1 minus 5, negative 4AB. Let's look at the next one. Negative a squared, positive 3a squared. When we put those together, negative 1 plus 3, that's a plus 2a squared. And then the last one's just regular numbers. Even though there's an exponent on that, the exponent is not on a variable. So this is just 4 squared, which is just 16, right? So we get 4 squared plus 16 plus 10. Wanted to rewrite that because I had to change 4 squared into 16. So we get negative 4ab plus 2a squared plus 26. Final answer. Next one. Here we go. 3p squared q squared. So where's my other p squared q squared? Here we go. P squared q squared. So now whenever I write those together, 3 minus 3, that's 0. Those just go away. Bye. See ya. P squared q to the 3rd, here and here. So whenever we put those together, we have negative 3 plus 4. That's just a positive 1, right? So p squared q squared. Nope, q to the 3rd. P squared q to the 3rd. And then our lonely pq right here. Has no like terms to put together with it. There we go. Final answer. P squared q to the 3rd plus pq. All right, now evaluating functions. It's basically just, or evaluating polynomials, just plugging them in, right? So 10a minus 15, that's 10 times a minus 15. And they're telling us what a is. A is 3. A is 3. So we're going to do 10 times 3 minus 15. 10 times 3 is 30 minus 15. 30 minus 15 is just 15. Final answer. Not bad, right? So do we have an A in here? No, we don't. We have B. So B is 5. There's a B here and a B here. So I'm just going to plug in 5 for B. Negative 5 times 5 to the 3rd plus 7 times 5 plus 10. See, everywhere I saw a B, I just plugged in 5. And make sure you use parentheses whenever you're plugging things in. So this is negative 5 times 5 to the 3rd. 5 times 5 is 25. 25 times 5 is 125. You know, 7 times 5 is 35 plus 10